data efficient processing performance model for the configurable big data frameworks by reducing the information overlap between the training examples. Good evening, everyone. My name is Ankit Singh, student of BE Computer Science and Engineering, and today we were going to discuss about the research paper which is published on the subject Big Data Analytics. So here's the introduction part. Problem statement is the performance modeling for the configurable big data frameworks is challenging due to the large number of reconfigurable parameters. So our goal is to build a data efficient performance model by reducing the amount of training needed, data needed, and through the maximizing information overlap between the training examples. So the context will be the big data framework such as Apache Spark Hadoop frame offers many configurations per parameter, making performance tuning complex. So the key challenges which we faced is gathering of the sufficient data uh, for the machine learning models and can be expensive and time consuming. So these are the challenges and the context goals and problem statement which was mentioned in the research paper. So the motivation is the high dimensionality. The frameworks like Hadoop uh, and Spark offers many tunable parameters such as memory and executors. So the current approach is which we just mentioned was requires a large, often redundant data set for the accurate performance modeling. And the goal was to reduce the training data set while maintaining prediction accuracy by focusing on unique informative examples. So the goal is to the goal we have mentioned. So the redundant data problem. So in the traditional performance, the modeling many configurations and settings results in a similar performance outcome. This is because the redundancy in repeated data sets were coming. That's why we are getting the same performance and mistakes again and again, which leads to the inefficiency of the model. So impact on the real world application is given as the environment where we are tuning the crucial for the performance and the inefficient total the quick decision making and the resource allocation. So the challenges in the existing approaches are the high redundancy, as I told, the repeated data sets from the given data, again and again repeating the data, which makes the model inefficient. So the data collection cost, so collecting the data from the numerous sources, and it is very expensive. So in the training models, we often requires a large amount of data, and it's not available very easily. Any inefficient model overlapping example lead to the less efficient and learning lower performance. So the research paper has proposed this approach. So the key idea is to reduce the overlap by strategically selecting the training samples that provides a novel information and diversity aware sampling, which introduces the technique that prioritizes the selecting of the diverse training examples. And the expected outcome, according to the research paper, was to improve the data efficiency with the fewer examples required for the training. And the core innovation was minimize the number of training examples while maximizing the information gained from each. And the information theory uh, basis is the strategy leverages the principles from the information theory to ensure that each example selects and the sufficient new information to the model, reducing the overlap examples and the model scalability, which is discussed later. So the methodology which is followed is identifying the configuration parameters, defining the where we are defining the parameter for the big data frameworks, diversity aware sampling, use clustering, active learning, and uncertainty based models to choose the informative examples. Model training building builds a performance predictive model using the machine learning to reduce the data sets, and model evaluation, which is assess the model accuracy, efficiency, and ability to generalize unseen configurations. So diversity aware sampling techniques. So in the research paper, it's the technique which we are going to use, clustering based sampling. So group of the similar configurations are diversely clustered and then active learning. So the selected data is used to predict and maximize the model's learning potential as they are not redundant. So after that, we are giving some uncertainty based sampling. Focus on examples with high prediction uncertainty to improve the model accuracy. And after that, the diverse sampling for the robustness, ensuring the diversity in the selected example enhances the model robustness by covering the edge cases and uncommon configurations. And the entropy based metrics, the methods employs entropy calculation to prioritize training samples that increase uncertainty reduction, making the model to learn more efficiently. So the evaluation matrices. So the prediction accuracy, how accurately the model predicts the performance metrics like runtime, uh, data efficiency, the reduction in the number of training example needed, and the generalization model's ability to predict unseen configuration efficiently, and the results, the proposed model achieved the significant accuracy with the fewer examples, reducing the data size up to X%, which is specific to the paper. Then the efficiency gains model built using the proposed approach shows the significant reductions in the training data requirements while achieving the similar better accuracy from the traditional models, and the cross-validation results and the data reduction rates. So here's the we came to the conclusion of the research paper. The data efficient performance modeling approach that reduces the number of training examples while maintaining the accuracy is very important. And the diversity aware sampling ensures the model to run effectively and fewer more informative examples like we are since our main objective of the paper was to reduce the data redundancy to make our model more efficient, so we were given different approaches for that. After that, some of the future works like extending the approach to the big data frameworks, we are often gonna uh, improve that model and explore the further improvements in sampling techniques like deep learning based diversity measurements. So here's the reference. So we have just the paper has been published in 28 November 2022 in the Science Direct, and here's the link. So guys, thank you everyone. We're gonna meet in the next video.